Now for some redox reactions, but before we get into redox reactions, we need to work a little bit on oxidation numbers. Okay, and oxidation numbers are always going to be positives. Okay, the negatives one are only for oxygen, okay, for most part, and halogens. Anyhow, let's work with oxidation numbers. So let's start with NaCl. So what's the oxidation number for Na? Okay, in sodium. So the way you work this out is that you look at the oxidation numbers of the anion, which is going to be -1. So then sodium must be +1, and that's the answer. Okay, very straightforward. For main group elements, it's not even hard because all you have to do is see what group number they are in. Okay, so for example, if you were to do for calcium nitrate, you know that nitrate is -1, and since you have 2 of those, then calcium must be +2. Okay, otherwise just look at the periodic table and you know that calcium is in group 2, and so it should have 2, okay, charge. All right, let's look at another one. Now in this case, iron 3 chloride, we look at the oxidation state for iron, and to work this out, again remember the total charge should be 0 because this is a neutral molecule. So -1 times 3, okay, plus whatever that we have should be equal to 0. Okay, so this, let's say x. Okay, so x plus, and then this is a total of -3 should be equal to 0. So x here is +3. Okay, and that's your answer. So that's how you kind of work it out. You have to work it out in a backward manner. Let's take a little bit bigger molecule now. So H2SeO4. Okay, remember total charge should be 0. Okay, so here we have hydrogen. We have 2 of hydrogen. Each hydrogen is +1. Selenium is what we are trying to figure out. So that is our x. And then oxygen, we have 4 of oxygen. Each oxygen is -2. Okay, and so then this should all be equal to 0. So let's go ahead and remove the brackets, do the calculation. So here we have +2, and then this is still x, and then we have -8, okay, for oxygen. So -2 plus what? -8 should be equal to 0, and so this number should be +6. Okay, so that's how you figure that out. Let's do another example, and this is a little bit more involved in the sense that let's find oxidation number of sulfur, okay, in the following. So now we'll work with 3 compounds, okay, which have sulfur. So SO2 and A2S, sodium sulfide, and then calcium sulfate. Okay, so let's work with these 3 compounds now. So here we have sulfur, which we don't know, and we have 2 of oxygen, and each of those oxygen is -2, and that should be equal to 0. So x plus -4 is equal to 0, so x then is +4. Okay, that's how you figure that one out. Now here you can actually use the sodium if you're trying to figure out for sulfur, because sodium is group 1. So if you have 2 of sodium, which is +1 each, and then you have sulfur, which you're trying to figure out, total charge should be 0. So 2 plus x is equal to 0, so x then is -2. Okay, so in some cases, yes, the oxidation number can be negatives. All right, and that's usually going to be for the non-metals. All right, let's work for this one now, since we have sulfur right here. Calcium is 2 plus, so 2 plus sulfur that we are trying to figure out, plus, now we have 4 of oxygen times -2, and -2 is the charge on oxygen, so +2 plus x plus, and then -8. All of this should be equal to 0. So again, x there is -8 plus 2, and that gives us a total of minus 6. Okay, so that is the charge on sulfur over here. So that's how you do the oxidation number for neutral compounds. Now we're going to take something a little bit different and try it with ions. Okay, because in case of ions, you should have a charge left over. All right, so taking for example VO2 plus. Okay, so let's take this one and see what the oxidation state for vanadium is over here. So now X plus 2 times minus 2, all right, is equal to plus 1. All right, that is how it should be. Previously it was 0, but now it should be plus 1. So X plus minus 4, okay, is equal to plus 1. Now you can do it algebraically if you want to. Okay, so which means that X is equal to plus 1, and then if you take the minus 4 on the other side, then it is plus 4, and that is equal to plus 5. Okay, so that is your final answer. Or you could just do it on the left hand side and see what number you need for X to add it to 4, negative 4, to get a plus 1, okay, at the end. So then let's take another one. And now I'm going to take MnO4, excuse me, minus. Okay, so now Mn, whatever Mn is going to turn out to be, and then oxygen, which we have 4 of, times minus 2 should be equal to minus 1. So X plus minus 8 is equal to minus 1. So without doing it algebraically, you need to have a minus 1 on both sides. Okay, so which means if X is plus 7, then plus 7 minus 8 is equal to minus 1. So then Mn is plus 7. Another one, let's take S2O3 2 minus. This is thiosulfate ion. So now we have 2x, instead of just 1x we have 2x plus 3 of, remember, minus 2 for oxygen. Okay, oxygen is always going to be minus 2 for most part, and all of this should be equal to minus 2. That is the overall charge that's left on the ion. So 2x plus, and now this is minus 6, is equal to minus 2. So if you want to do this one in an algebra form, you can do this. So for example, then 2x is equal to minus 2 plus 6, which is equal to plus 4. So that is 2x. So which means that x is equal to plus 4 divided by 2, which is then plus 2. Okay, so that is how you would do it for the thiosulfate ion.